someone to love. 'Cause you need to get back in the arms of a good friend. And I need to get back in the arms of a girlfriend. I didn't know nobody, and then I saw you coming my way. I didn't know nobody, and then I saw you coming my way. Don't you need to get back in the arms of a good friend? Oh, 'cause honey, believe me, she'll love to call you my girlfriend. Don't you need to get back in the arms of a good friend? Oh, 'cause honey, believe me, she'll love to call you my girlfriend. 'Cause you got a good thing going, baby. You only need somebody to love. Well, you got a good thing going. You're only looking for someone to love. 'Cause you need to get back in the arms of a good friend.
So let's go ahead and there we go. All right, there we go. Hopefully that works now. Sorry about that we lost audio for a second. All right, I'll make sure that that it's on there in the next 10 seconds here. But in any case, we were doing is we were going from the publisher table to the game table to the availability table to the platform table. And so again, I don't have to have any guesswork here at all to make sure that all of those work, because everything is Yep, there we go. Sorry. Yep, sorry. Now it's working. Anyway, there's no guesswork there at all. Now, I'm going from the publisher table to the game table. Now I'm going to go over to the availability table. So join availability A on. Now, how do I bring the game table and the availability table together? Well, again, if you're going from the game table, there's no guesswork here. G.GameID, that's the primary key, is equal to A.GameID. That's the foreign key. The foreign keys are named after the primary keys that they reference. Right? Nice conventions all throughout. Now let's go ahead and join over to the platform table, P on A.platform ID is equal to P.platform ID. Now if I just did this, it's going to error out. And why? If you can read that down there, it says there's not a unique table alias P. Remember that I've aliased these tables by using P or G, A, P. But if I have two aliases named P, two different tables, can't have that. So I'm going to go ahead and alias this one as plat instead. Why? Short for platform. Or maybe I don't alias it at all, and I use the full form, platform, and just platform. There we go. G dot publisher. Sorry, where did I screw up? Oh, thank you. There we go. That was just mistyping, not bad naming conventions. Thank you. I did reset this to just the core games here. But the problem with this immediately is, well, one problem I see is that I see too many columns. For example, publisher ID here is repeated twice. But also, does it matter if you're producing a human readable report? Does it matter what these numbers are? Do you want to see these numbers? If you're a DBA, a database administrator, certainly you need to know what these numbers are because I need to delete the publisher ID with ID 10, right? But I can go in and query that out. If I want to produce a report, I don't want these numbers here at all. I just want the game name, the publisher name, the game name, and the year published maybe, and then finally the name of the platform. So let's do that. I'm not going to select everything. I'm going to select p.name, comma, g.name, comma, a.publishyear, right, comma, p.platform.name. Right, there we go. And now that's much, much smaller. Now consider if you were sending this over the wire. And in fact, it is being sent over the wire. But suppose that you had a large application sending tens of thousands or millions of bytes over, megabytes, gigabytes, right? Are you going to send redundant data over or data that on the other end you don't care about? No. You need to be more intentional about that, okay? Now, the other thing I see here is name, publisher, name. Is that going to be all that useful to a human? No. Let's go back in and give them aliases. As publisher. You can go to the next line here. There are some conventions that you indent values like this, and then you come back out for keywords, but not all the way out. You still want some indentation or something like that, but as title, right? Publish year as year. Actually, let's leave that one for now. And then, oops, sorry. And then finally, platform name as platform. From, and then I'll go back out here, right? As long as you're following a consistent convention, that's fine, right? But definitely don't do really long lines. That's not readable at all, right? There. Now I've got publisher, title, publish year, and platform, okay? Going back to your question last week, well, publish year, if I want this to be a little bit more human readable, it would be year published, right? And I want a space in there. If you want to do that, then you got to backtick it, right? And then now it's a nice title for a human user rather than a computer user, okay? Year published up there. Okay, that's good, except that I don't see any of the publishers in there that don't have any games published. For example, Sony, Square Enix, et cetera, et cetera. So what is the difference? A join, and then what's the other kind of join that we looked at? A left join. Right? Left join, left join, left join. I'm joining all the way through because if I didn't, if a publisher had a game, but that game was not available on any system, we would lose it when we go from these two tables to this third table over here. So left joins all the way through. Right? And there's Sony Entertainment all the way to the no title, no published games, no platforms. Again, if I only gone one left join there, right? Left join, there we go. Then I'm going to lose all of those because I lose them not here, because I am doing a left join there, but I end up not doing a left join over to the availability. Consequently, there are no matched records, and you don't get, and they get lost in the entire thing. That's also not enough, right? You have to left join all the way over. There. Now I get Sony all the way over. Except that the problem that we left off last time was we put in Valve Index and Playdate, and they are in there. Let me show you. Select everything from platform. There we go. Platform. There we go. Right. And there. Steam. Actually, so not Valve Index. I redid it, and I did Steam Deck and Playdate. Right. Steam Deck's newer than the Index anyway. Right. So Index is the VR, but put out by Valve. Steam Deck is the handheld, right? Full Linux system, right? Have you seen? I think I showed Playdate last time. The crank, little crank one. All of those are great. Anyway, those records are not preserved here. Why? I'm preserving from the left. Okay. I want to preserve everything all the way through. I want platforms that may not have any games published on them yet. Right? So, what could I do? Let's get rid of that. I could reverse all of this. Right? Oops. Let me go ahead and leave that. And let's get rid of that. All right. So I'm not going to start at the publisher table. Instead, I'm going to start at the platform table to preserve records from the left. So from platform, and I won't alias that, and then left join to the availability, move that one down here, on platform, and I need the, let's see, platform ID, I need this one, right? Then I do a left join to the game table on this one. Nope, this one right here. So I'm just going in reverse here. I'm rearranging all this stuff. So I'm going from the platform to the availability on their platform IDs. Then I can go to the game on g.game or a.game ID is equal to g.game ID. Right? And then finally over to the publisher. Left join to the publisher. Get rid of that. On publisher ID. And that's going to be a g.publisher ID and then p.publisher ID. There we go. What did I screw up? P, where's publisher? Thank you. P, right, there we go. All right, great. Now, I'm getting Steam Deck and Playdate down here because I'm preserving from the left, but I have reversed everything. Imagine taking this and simply just taking the mirror image. I'm going from the platform to the availability to the game to the publisher, right? Preserving from the left. Okay, but I'm also losing something. Since I'm only preserving from the left, what about Sony? They're lost now, so I'm back at square one, right? So what I'm going to do is I'm not going to preserve from the left. I'm going to, first of all, preserve from the right, right? Let me go ahead and copy this, and instead of a bunch of left joins, I'm going to do right joins. Right join, right join, right join. Now I'm going to preserve from the right. In other words, I'm going to read left to right, but preserving from the right. In other words, it's going to preserve those platforms. Steam Deck and Playdate are right down there. But Sony Entertainment, whoever else was missing, right, they're not there yet. What I really like to do is to have this and this together in one query, right? I want to preserve from the left and preserve from the right at the same time. So let's go back to our set theory over in, say, 235. If you've got two sets, A and B, how can you combine them together? What are some operations? What's one thing you could do? Add them, and that's called union, right? So let's come over here and do a union. Right? I'm going to take away that semicolon because this is one result set. It is a set. Right? This is another result set. It is a set as well. And I'm going to take the union of those two things together in one big giant query. Right? Now things are preserved from the left. Sony Entertainment, null, null, null. Things are preserved from the right. Steam Deck and Playdate, null, null, null. Right? And I'm not getting duplicate values. For example, let's see, LucasArts TIE Fighter, 1994 on PC. That only appears once, period. Why? Because these are sets. And sets are unique. If you have sets that aren't unique, those are called multi-sets and with multiplicity, and that's not what this is. Right? I do have LucasArts several times, but that's because they published multiple games. I have Lego Star Wars 4 times, but that's because they were published on 4 different platforms. It's the entire tuple, the 4 tuple here, that is the unique element. Right? So this is a set of what? A set of tuples. Each tuple has 4 things in it. Right? Okay. Can you also do intersection? Intersect. Yes, you can. Even though it's complaining about it, it runs. Right. Don't ask me why MySQL Workbench is complaining about this. Probably because it's might not be core, whatever dialect we're using here. But it still actually runs, right? Now, am I getting any of those records that have missing things from the left or the right? No. Why? Because what is the intersection of 2 sets? Cap, right? It's everything in A and everything in B. If you look at the Venn diagram, right? Circle, circle, only the things in the intersection are preserved. Well, what are the things in the intersection here? The things that are preserved from the left and from the right. In other words, things that were in the original query. Right? You don't need to do this intersection at all. Just do a non-left join. Just do a regular old join. Right? But yes, you can use intersect. Right, there we go. So we've come full circle here. We started with, say, patient data in your first assignment that gave you this data model that was all flattened. A bunch of CSV files, right? And what we did was we normalized. There's a process called normalization that we'll talk about eventually, where I separate things out into different tables. I relate those tables together to reduce redundancy. That game title is not repeated 1, 2, 3, 4 times until you do a big giant query to flatten that entire data model out to take it back to a CSV file, right? So flatten the entire data model. And you can also configure this to output not something that looks like Excel, like that. You can output it to look like a string with a bunch of commas as delimiters. Right? There's a utility called MySQL dump that will dump an entire database with SQL code to reinsert everything so that you can back something up. But otherwise that's the entire data model flattened down. I'll make sure that you've got this in the notes, but before we go on to the next thing, is there anything else that you want to see, at least with this data model over here? Because in your lab on Wednesday, you're going to be doing basically the same thing that we've been doing, you know, a series of queries, a dozen queries or so, but it'll be an albums database instead. Albums and band members and bands, and so there are 6 tables there. It's a little bit richer. Anything? No? All right then, let's move on. All right. What I want to do is I gave you that data, right? We started with a complete database already designed with data in it. What I want to do is I want to go through that process from scratch, right? We're not going to design the game database because we've already seen that. Instead, what we're going to do is we're going to create a data model for our accounts, right? So remember that we have these accounts, we have an asset, annuity, and stock, right? As well as persons, that's owners, and their emails, right? Okay? So all of those things, I want to create a database to support that. Just let's go ahead and come back over here and remind ourselves of what that looks like. I've got a stock, a person, an ownable interface there, an annuity, an asset. Is that everything that's relevant? Dog, film. Yep, that looks like it's fine. Take a look at what that looks like again. All right. So we've got an asset class, and then we've got two subclasses to it. Up here in the asset class, we've got, it is abstract, even though Plant UML is not correctly doing it. We've got an abstract method here, get value, because is there enough information up here in the abstract asset class to determine how much it's worth? No. Only when we come down to a stock class and we have the number of shares and the share price, can we multiply those two together and say that this is worth $1,000. We've got 20 shares at $50 each. Right? Or the annuity class over here, terms times monthly payments times 12. Right? It is slightly different behavior. Okay? Over here, we do not have inheritance. This is a different arrow right here. Instead, this is saying that an asset owns a person through composition, or a person owns, yeah, that's what it is, because there is an owner there, and it's not actually depicted here. If we didn't highlight person, then it would be depicted up here, but because we highlighted person, it's showing that there's an owner over here. There's one owner for that asset. And it's comparable because we like our people to be comparable so we can sort by them. And then finally, everything down here is ownable. That's the interface. Ownable is like get owner or something, right? Okay. Let's go ahead and model this into a database. Before I do that, let's go ahead and take a look at the person class here because I want to model a person first. All right, okay. We've got a last name, a first name, a date of birth, and an email. On email? I said on email, is that correct? Nope. What do we have? A list of emails, right? I shouldn't have closed that, right? But what kind of relationship does that tell you when you think about a database, though? So one publisher can publish multiple games. One game has one publisher. What kind of a relationship was that? One to many. So what kind of a relationship is that here from a person to their emails? One person has many emails. When you have a situation like that, what should you do? Create two tables and a relationship between them. So over here, let's go ahead and start with the email, the person table. The email table, sorry. All right. So to create a table, you use create table. You got to spell it correct, though. Right? So who would have thought, right? Pretty straightforward. Create table, email. Right? Now I'm following a more modern convention here. The video game database, all the table names were all lowercase. And that's fine if you want to do that as long as it is consistent. I'm following an upper camel casing convention here, email of person. Right? That's a terrible name. Do not use that name. I'm just using that to show you that this is an upper camel casing convention, right? Or upper snake casing, some people call it, right? Why? Because I'm thinking ahead. I'm going to have my Java classes, and there's probably going to be a one-to-one correspondence from my Java classes over to my tables. And if they all have the same name, wow, right? There's no guesswork there at all. The email table is going to be, the person table is going to have a correspondence to the person class. Right? We're not going to have an email table, a class over here in Java. You can, right? What would it look like? Email, and then new class email. Right? What would it look like? Private string address. Right? It's just a string, so Yagni, yet, right? Yagni, you ain't gonna need it, and what I put at the end there was yet. Eventually, if you do want a database connection, you're probably gonna want something else. How do you uniquely identify records in a database? An ID, right? So email ID, right? So you ain't gonna, Yagni, you ain't gonna need it yet, but maybe in the future you do, right? In which case, I'd come back and I'd refactor this so that it's an email record, right? You ain't gonna need it yet, right? Let's go ahead and create that email table. So I shouldn't have closed it, darn it. Just a second, let me open it back up. Where's my video game database? Nope, game database. There we go. All right. So what commonality do you see in every single table? First thing in every single table, a key. If you find yourself doing anything, right after create table, the first thing you do, right before you even think of anything else, is going to be a primary key. Name it after your table. Slap an ID at the end, right? Follow that convention everywhere, and you'll be fine, right? And it's going to be an integer, primary key, not null, auto increment. There we go. Comma, right? Everything that we put in these parentheses here is going to form the email table. It's very much like a structure in C or a class in Java, but we're going to be using parentheses. There is a semicolon at the end, okay? If you follow this convention, there's no guesswork whatsoever. If you follow blindly, just go ahead and slap that on every single one. You get what's called second normal form for free. We're going to talk about first normal form, second normal form, and third normal form. In my opinion, second normal form is the hardest to understand. But it doesn't matter because I just do this anyway. Right? It's a good practice, and you get second normal form for free. Right? It's going to be an integer. Why not a string? Right? Why not a double? Right? Why? Because integers are precise. 5 is equal to 5. What about doubles? 0.999999999. Is that equal to 1? Nope. Except sometimes, right? 1/3 times 3. Is that equal to 1? Sometimes, not necessarily, right? These things are very, very imprecise. This number and this number are equal if they're floating point numbers, if they are close enough. That's our standard, right? And so if you use this double, how do you know that that email is equal to that email? Are they close enough? Close enough ain't good enough for a database, right? Why not varchars, 255s, right? What's the problem here? If I have email 001, email 002, email 003, right? Is that the same thing as email 001? Is that equal question mark to email 001? Is it equal question mark to email? There we go. I forget what that's called. That's caps, right? Alternating alt caps going up and down like that, right? Are those things equal? In my mind, no. But in some SQL implementations, they are, because you don't know if case sensitivity has been turned off or on at the query level, at the table level, at the data creation level, right? Huge headache. I don't know if this person that set this database up correctly or not got it right, and if they didn't, or the configuration right. And I'm not gonna be forced to play a guessing game like that. So I'm going to only use integers. Integers are precise. 5 is equal to 5 everywhere. Right? I'm going to slap a primary key on this so that it's uniquely identifiable. Right? And that's my primary key. I'm going to say that it can't not be null. The default is that it's allowed to be null. But since it's a primary key, should I allow this to be null? I mean, you can only ever have one record with a missing ID. I don't want any records with a missing ID. So I'm going to say not null. Auto increment, again, key management is a very difficult problem. Let the database take care of it for you. Right? I'm going to let it auto increment and assign the next available value. 1, 2, 3, 4, right? Etc. What else defines an email? Well, if I'm looking forward and I do something like this, what else defines an email? The address. So slap that on. And what is it? Are email addresses integers? Nope. Email addresses are varchars. You do have to put in a number there. When you define a varchar, the default value just that pops into my head every single time is 255. There's some historic reasons there. Now, as I've got it, that comma there, it's allowed to be null. Should we allow it to be null? You create an email record for this person over here, but there's no address. Right? What happens when you try to send an email to that null address? null pointers, right, come out of your Java code. Maybe it crashes your system. Maybe that cascades and everything just completely dies, right? Not a good idea. If that's required data, then make it required, not null. Right? Okay? Now, if you put that in there, when you create data, you're not allowed to create it without specifying the address. You will never be allowed to update data to set the address to null. Right? You will never be able to, I guess that's the only two things, update and destroy, or you can destroy it all you want, right? Just delete that email address. But now we've got an assurance here, right? We've got a constraint that says your address is not allowed to be null. Anything else? Whose email address is this? How to connect this to a person, ... All right, so I'm going to put that into a comment to do, right? Well, first of all, I need a person, right? So let's create another table, person. I'm following the same conventions, upper camel casing here. I am not pluralizing anything. Right? It is the person table, not the persons table. It contains person records, right? What's the very first thing I should do, blindly, without question? ID. Copy pasta that, but then it's person ID. Right? Auto increment, not null, int, primary key. Okay? What else defines a person? Yeah, go ahead.
Does the order matter?
The order generally does not matter because when you insert data, you specify the column. So I could specify address, comma, email, ID, right? When you write it though, always put the why are you putting the primary key at the bottom? Put it at the top where it belongs, right? It might matter over here when it actually generates the CR diagram, but generally the order does not matter, right? Note here that it's not compiling over here. There's a red mark right here, and that's because the Oxford comma that you might be used to in C is not allowed, right? If that's your last field, if that's your last column, then you cannot have a trailing comma there. I'll get rid of it for now. All right, what else defines a person? Name, okay. Name, varchar 255. Just one name? Okay, good, right? It's a good idea to split these things out, just like we did in Java. Right? First name and last name. If you want to go last name, first name, it doesn't matter, right? Because you're going to be specifying the column names when you insert data or query data. Right? The question here, though, is should these be allowed to be null or not? Okay, I think you have an argument for last name, not null. But do you have an argument for the first name? I don't know. What about Prince or Madonna? Right? Or, you know, those are stage names, those are pseudonyms. So maybe they probably do have a first name, right? I don't know what it would be. Yeah, I don't know what it is. But sometimes some cultures don't have a first name, right? Sometimes some cultures have multiple names, right? So how are you going to support those things? Sometimes you want to support a preferred name or a changed name or a maiden name, et cetera, et cetera, et cetera, right? So how are we going to support that? Well, I don't know yet. If you wanted to go that far, you'd be going back to the stakeholders who are paying for the system, and then you do what's called requirements elicitation. You are eliciting requirements from them. You'd ask them those questions. Do you want to support maiden names? Do you want to support change names? Do you want to support this and this and this and this? And if the answers are yes, then you come back and you make new columns. And you'd also ask them, would it be considered bad data if they didn't have a last name? I don't know. We want to make sure that we've got plenty of customers, even if we don't know what their names are, right? So no, it's allowed to be not there. Okay, good luck running your reports, right? For variety, I will allow this to be null. So allowed to be null for reasons. Right. I'm going to put reasons in quotations there because all I'm really doing is showing you the different syntax. That if you do not have not null, the null is allowed to be it, right? This is the default, null, right? Instead of not null. Okay. What else defines a person? Certainly their emails, right? In fact, if I looked at the Java version over here, let's get rid of that, then they have a string of emails. Right? So would it be correct to have an email reference here? Right? What would that mean? So say that there's an email ID here. Right? A person can have how many emails? One if I do that. Right? So I'd have to do something like this. Email ID 1, email ID 2, email ID 3, right? And some systems do this, right? Where we want to support up to 3 emails. We don't need another table, right? Except that what happens when somebody deletes this one and retains this one? Do you upgrade the second one to the first, right? This is allowed to be null, this is allowed to be null, but this one's not allowed to be null. They always have a primary email. In fact, that's what people do. They go primary email, secondary email, right? Tertiary email, right? ... How many email addresses do you want to support, right? I alone have at least 5 email addresses, right? At least, so cburk3, the alias chris.burk. I think I also have a Huskers just because, a UNO address, and finally our legacy CSE address, right? They all go to the same one now. So if you email any of those, they'll all go to the first one there. But 3 is probably not enough now in today's day and age. Besides, you have your personal email, your school email, your work email, the email that you use to sign up for stuff so you don't get spam, right? Et cetera, right? So we're not going to have an email, we're not going to enumerate them because that would mean that you're only allowed 3. That's not a one-to-many relationship. That's a 1 to 3 or 0 to 3 relationship, right? And it's not going to be here, email ID. That would mean that it's a one-to-many relationship over here with the email table. And that's wrong. That's reversed, right? If you want a parent-child relationship here, right? What is the analog here for publisher and game? The publisher is the parent, the game is the child, and therefore the foreign key is in the child, referring back to the parent. Email, person, which one is the child? This one's the child. This one's the parent. So where does the foreign key belong? Right here. Person ID, right? How to make this a foreign key, ... We'll come back to that, okay? Let's go ahead and finish out the person first. What else do we want? A, date of birth. Date of birth. What kind of, what should that be? Over here in Java, what is it? A built-in local date, because that's well designed. There is a date, by the way. Right? It's legacy. It was not well designed, which is why they made local date. It is well designed. Right? Over here, we have the same problem. Yes, you do have a built-in date, as the blue indicates. It is not well designed. It sucks. Right? It is not interoperable. You take this from a MySQL database and you take it over to another database, and it'll be completely different behavior. Don't have those headaches. Make it into a varchar of some length here. Right? That length is going to be an ISO 8601 standard, but one that we're used to. 2024, today is May 4th. Right? Oh, it's Star Wars Day. We all know Star Wars Day, right? Or no, it's not May, it's March, sorry. 2 months from now, it's going to be Star Wars Day. May 4th. Why is it Star Wars Day? May the 4th be with you? Ha ha ha. All right, so no, sorry. I thought it was May already. That would be great. It would be almost done, right? The semester would be almost done. But anyway, this is going to be an ISO 8601 standard. It is going to be a lot easier to work with this as a string. How big is that string? Does it need to be 255? In fact, if you're inserting anything more than 10, I'm going to say, that doesn't look like an ISO 8601 standard to me, right? So I will go ahead and keep it like that. Should it be allowed to be null? Maybe we don't have their birth dates. If it's allowed to be null, let's go ahead and also give it a default value, right? so that it's not null. 0, 0, 0, 0, 0, 0, 0. That's a wonderful default value. Why? Is there such a date? Nope. Oh, there is no year 0, right? There's just a year 1, right? 1 BCE, and then we immediately jump to 180 or whatever it is, right? Common area, CE, right? There was no year 0, right? There's a movie called talking about just that, right? Year 1, Jack Black, isn't it? Okay, I don't know, whatever. Anyway, you can define default values here to be default. Yeah.
So when you like put in the 10 in the bar chart, you don't have to like think about like a no term.
Oh, no. Nope, no term. Old school you did. That's why this is 255. Because they knew, oh, we want one less than 256, which is 8-bit addressable, knowing that they're going to need to be putting in a null terminating character there because we're in 1970, 1980s. But no, you don't need to do that. Right? It takes care of it for you. 255 is just a historic quirk. Right? Last names, 100 is good enough. Right? Until you find somebody with a last name that is super, super long, and then, nope, not good enough. Right? But this is definitely good enough for an ISO 8601 standard. 4 plus 2 hyphens there. Okay. Oh, by the way, we did gather all of. It was posted on Piazza, but we did gather all of the. What do I want to say? Test cases, and we also culled all the ones that didn't make it. We still gave points, or at least partial credit, for the ones that didn't make it. You might not have made it because you had bad formatting, like this. That's not the ISO 8601 standard. You might have had month versus like the 24th month instead. There is no such thing as the 24th month, right? Some things also had bad data because they were missing a salesperson or something like that. Okay, so we took all of those out. Everything should be good data. I think we have like 10 that survived. There are 10 test cases. 5 are randomly served for you, and among all of the, then we turned on all of the rest of the grading for the rest of the semester using those test cases. So if you see any issues with any test case, let us know immediately. Make sure that you're giving us the test case number, not the number that it appears. There are 1, 2, 3, 4, 5, but the number like ours is test case 001 or something. Right? 01, I think it is. Right? Okay, so that's a pretty good idea of a person there. What about bringing these two things together? So to bring these two things together, I need to specify it as a foreign key, right? Where is it? Yep, there we go. To do that, I'm going to give it an entirely different, well, first of all, I need to finish it out. Person ID is an integer, not null, right? Those two things are essential. If person ID is going to match this person ID, then the types need to match, int. If you made one of these a varchar and the other one an integer, 255, right? Then it's going to be doing apples and oranges comparisons all the time. It's going to try to change this into an integer for the purposes of comparing this down here. Good luck, you're rolling the dice there, whether or not it works. Make sure that they match. Not null. What if it were allowed to be null? If it were allowed to be null, then this person could have we could have an email record without a person. Those are called orphans. We don't like orphans in our database, right? Orphans are great in real life, but we don't want orphans in our database, right? Whatever, right? Well, I guess they're not, right? But whatever. It's terrible naming conventions, and I wish that there was something else to name them, but it's parent-child relationship. There's actually quite a few movements out there to try to change these legacy names to something much better. Like for example, GitHub, right? GitHub has a default branch called main now, right? Unfortunately, the core Git folks have not changed over to that. GitHub has, but the core Git tools have not. That's why you still have a legacy referring to master, right? They want to get rid of that kind of legacy terminology. So I wish there were a better terminology for child, parent, orphan, right? Whatever. But I don't know. Anybody think of a better one? I mean, missing referenced record is not that great, but whatever. Anyway, person ID, not null. right? We do not want non-referenced records in our referencing table, right? That's the technical term, but that's a mouthful. There's got to be a better way of putting that. All right, now let's make it into a foreign key, right? I'm going to make this into a foreign key, right? Spell it correctly, foreign key. And I need to specify what the foreign key is. The foreign key is person ID, right? What do you reference? Reference is, right? What table are you going to reference? Person. And what column are you going to reference in that referenced table? Person ID. There. Now let me run all of this. I'm going to run the entire thing and it's going to fail. Right? It's going to fail right here at the email table. Error code, can't create table email because foreign key constraint is incorrectly blah, 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 blah. What's the problem here? Yeah, it's just like C. If you have a structure within a structure, the order matters. If I'm referencing the person table down here, does the person table exist yet as of line 9? No. So let me move that up here. There. Okay. Now if I run the entire thing, it should work. Right? In fact, let me show tables. Right, there we go. Email and person. You can even describe them. Describe email. And you'll see that it's exactly as we wrote it. There's an email ID, an address ID, a person ID, which is a foreign key. MUL, M-U-L, is the reference for a foreign key. Primary key. No, it's not allowed to be null. No, it's not allowed to be null. This one's an integer. This one's an integer. That one's a varchar. And this one's auto increment. What's the default value? Nothing, nothing, nothing. But over here in the describe person, then we do have a default value here, 0, 0, 0, 0. Right. All right, wonderful. Let's continue. Actually, maybe I also want a middle name now. Middle name, varchar 255, comma. And I'm going to allow that to be null. Let me rerun the script. Fails. Can you create the person table if it already exists? Nope. All right, so before I even start, let's go ahead and drop that table. Drop table person. Drop table email. Be careful. Dropping a table drops all the records into it, no undo, right? If you've backed up the database, great, then you can always restore it. But as I have it right now, there is no undo. Person email. Let me try it. Still fails. You cannot drop that table because email table references it. If I create it person, then email, right? Then what order do I need to delete it in? The child table, then the parent table, reversed. There, all of that now works. I can drop the table, I can drop the email table, drop the person table, and then recreate them. Except that if I get in the habit of running this script over and over and over again, I get into a indeterminate state where I've already dropped those two tables. So if I run this entire script again, it's not going to work. You can't drop a table that doesn't exist. So it's always best to put on conditions. Drop table if exists. Drop table if it exists. That'll save me time, right? Because now if I drop the table over and over and over again, even though it's gone, it's just a warning, right? That's what that little yellow triangle is now, okay? Well, you can do the same thing for creating a table, except that only create it if it does not exist. Not exists, right? Not exists. Or if not exists, sorry. Forgot my if keyword. If not exist. All right, it is correct. There. Now I can run this over and over and over and over and over again, and it'll work no matter what because I've got these conditionals on this. Right? That's just the email and the person table. Now what we need is a stock, asset, and annuity, something like that. This is an inheritance model. This is an object-oriented programming model. Object-oriented programming models came to be in the late 80s. The database model, the relational data model, that started in the 70s. We've got a disconnect here. These two things are not compatible. How do we make them compatible? Right? How do we make them compatible in your CSV files? How do you know that this employee is a salaried employee or an hourly employee or a temporary employee? Or the items that you're using in your project. We use P for product, we use L for lease, we use et cetera, right? That's how we're going to reconcile these two things. That's called a discriminator column and a discriminator value. How do you discriminate, again, unfortunate wording, but how do you discern between these two things, right? It should be a discernment, right? It should be discernment column, and let's go ahead and just start calling these new things, right? Discernment column and discernment value. Unfortunately, I know of at least a dozen libraries that use the word discriminator column, right? I mean, yeah, it is what it is. So all this stuff is called the Overton window, if you're familiar with that term. Language changes, acceptable language and unacceptable languages change over years. So we're talking about language that goes back 50 years. Some things that were acceptable or not acceptable back then are acceptable or not acceptable now today, right? Anyway, the Overton window has changed. It's a window of acceptability, right? And this window moves throughout time and changes, right? All right, so we'll continue there next time building this database.